Hello everyone. So this is a question from JEE Mains 2026, 6th April Shift 2. Given is a concentrated solution of a weak electrolyte AxBy of concentration C and dissociation constant K, the degree of dissociation is given by. Okay. So the chapters involved is electrochemistry. So let's take an example of dissociation of Al2SO4 thrice. Okay. And obviously let's say its concentration is C. Okay, so we need to understand few things. So we know that Al2SO4 thrice, that is aluminum sulfate, will undergo decomposition to or dissociation to give me 2Al plus 3 ion plus 3SO4 minus 2 ion. One thing to observe is the charge on aluminum is plus 3, the charge on SO4 is minus 2, and also the number of aluminum ions is 2 and the number of sulfate ions is 3. Okay, important observation. And obviously at time t equal to 0, the concentration of aluminum sulfate is C and these guys are 0. Let's say that the degree of dissociation is alpha. Okay, we know that degree of dissociation alpha is equal to number of moles dissociated divided by number of moles taken. Okay, so therefore number of moles dissociated is going to be, and the number of moles that we have taken is C. So therefore number of moles dissociated is going to be C into alpha. Okay, so that is after, let's say after time t, therefore after time t from C alpha has dissociated. So how much will be left? Obviously at time t, C minus C alpha will be left. Okay, and also the amount of Al plus 3 will be 2C alpha, and the amount of sulfate ion SO4 minus 2 is going to be 3C alpha. Okay, so this is 2C alpha because you can see 1 mole of aluminum sulfate dissociates to give me 2Al plus 3 ion. Similarly, C alpha will dissociate to give me 2C alpha Al plus 3 ion. Similarly, the concentration of sulfate ion is 3C alpha at time t because 1 mole of aluminum sulfate dissociates to give 3 moles of sulfate ion. So therefore, C alpha will dissociate to give me 3C alpha of sulfate ions. Okay. So, after understanding these things, let's do the same thing for AxBy, our weak electrolyte. Okay. So this guy will undergo dissociation to give me y plus x moles of ay, minus, yeah, so I'll be having x moles of ay plus the other ion will be b x minus and y moles. Okay, so you can see the charge on A is y, the charge on B is x. Okay, and also the number of moles of ay plus formed is x and the number of moles of bx minus formed is y. Okay, so this is the dissociation equation for AxBy. And at time t equal to 0, the concentration of AxBy is given to us as C, and obviously ay plus will be 0, bx minus will be 0. And at time t, the concentration of AxBy is going to be C minus C alpha. We are assuming the degree of dissociation as alpha, and here it will be x into C alpha and y into C alpha, because you can see 1 mole of AxBy gives me x moles of ay plus and 1 mole of AxBy gives me y moles of By minus. So therefore C alpha moles will give me x into C alpha moles of ay plus, and C alpha of AxBy will dissociate to give me y into C alpha moles of bx minus. Okay. Now, the equilibrium constant, that is the dissociation constant of this reaction, is given to us as K. So therefore K will be equal to x C alpha, the concentration of Y plus raised to the power, stoichiometric coefficient is x, into concentration of Bx minus is Y C alpha raised to the power, stoichiometric coefficient is y, divided by concentration of AxBy is C minus C alpha to the power 1, because the stoichiometric coefficient is 1. Okay. So expanding all these powers, so I will have x to the power x into c to the power x into alpha to the power x into y to the power y into c to the power y into alpha to the power y, divided by c taking common 1 minus alpha. Okay. Now we can club these terms together. So I can write x bar x as x bar x itself, y bar y as y bar y itself. Okay, observe, look at C. C has powers x, y, and also 1 in the denominator. So it is going to be x plus y minus 1 because it's in the denominator. So it will be c to the power x plus y minus 1. And also we have alpha to the power x, alpha to the power y. So ultimately it will become alpha to the power x plus y. And in the denominator we'll be left with 1 minus alpha. Okay. Now, so this is equal to our K. Now in the question, it is given that AxBy is a weak electrolyte. So therefore alpha is, going to be lesser than 1. So I will write alpha is, lesser than or very small compared to 1. So therefore 1 minus alpha, I can approximately take it as 1. So because of this approximation, the denominator becomes 1. Okay. So therefore K is equal to x to the power x, y to the power y, c to the power x plus y minus 1, alpha to the power x plus y. And I can bring these terms to the LHS. So therefore alpha to the power x plus y is going to be k divided by x to the power x, y to the power y, c to the power x plus y minus 1. Okay. And hence I can write alpha as k divided by x to the power x, y to the power y, c to the power x plus y minus 1 to the power 1 by x plus y. Okay. So this is the correct value of our degree of dissociation alpha. Okay. Thank you.